Today is oh this is about the third time that I've asked you to take notes and that our notes have started with these words. Um, so it's like, wow, we've done this before. Yeah, I know, but like the first time I asked you to evaluate functions, and I don't think I'm going to write some stuff in red. I wouldn't write what's in red if I were you, because you'll look back maybe and wonder what it was I talking about. The first time I asked you to evaluate functions, I would have given you a function like this, and I would have asked you to evaluate it to find like f of -3. And of course, you just put -3 in place of x. -3 plus 5 is 2. So that the first time we met this concept, we were just plugging numbers in place of letters and we were done. The second time I asked you to evaluate functions was a couple of days ago, and most of you weren't huge fans, and some of you might still not be huge fans of it. I would have given you two functions like f of x equals 3x minus 4, and then another function like g of x equals x squared plus 1. And I would have asked you to find something like f of g of 3. And this is what some of you are still slugging through is that assignment 14, where you have to find one answer and then plug that answer back in to find a second answer. So these are our two exposures so far to evaluating functions. What's that? The third one is going to be today. And so I would start taking notes now because the new stuff today is I'm going to give you a function like f of x equals 2x minus 9. And I'm going to ask you to evaluate it at this. We can't get through a lesson on functions or a unit on functions if we don't understand that we're not always putting numbers into functions. Sometimes, and I'm going to finish the title of the notes here in a second. Sometimes we're not putting numbers in, we're actually putting what we call algebraic expressions. So today's notes are we're evaluating functions with algebraic inputs. So again, we're not putting in, we're not going to get answers today like 5, -9, 37, stuff like that. We're going to get answers today that still have variables in them. Because if I feed variables into a function, it has no choice but to give me back some version of the letter that I put in. So just like Monday's lesson, this is off the charts easy, but only when it clicks. All right. And I think that based on like how much stress you felt Monday and maybe some of you yesterday, this should feel a little bit more relaxing than that last stuff did. So here we go. So the way functions have always worked is you have your function rule. That's what's in the purple box. And all you're ever going to do is just follow directions. And if someone says, hey, go find me f of something, you know that that just means you take this something and you change it in place of the letter. And so, I mean, it's the same thing I would do as if it were a number. I'm just going to take the what's in the purple box and I'm going to write it over again. And it's going to say 2 times blank minus 9. This is what we've always done. Those of us that show our work especially are very comfortable with that step right there. That's just 2 feeding slot minus 9. What's going in the feeding slot? Not -2. K minus 2. So this entire quantity is going to transfer itself in as an input. And as you work that out, you will get, when you're done, an expression containing a variable. It's not going to be just a number. It's going to be a variable-y thing. So at this point, the math becomes just fundamental algebra basics. And so we are going to distribute the 2 because we have no choice. What do we get when we distribute the 2? 2k minus 4, and then we copy down the minus 9 because that was part of like the OG function, right? You got to bring it down. And then you finish the job by simplifying. Put your like terms together. What is 2k minus 4 minus 9? So our answer is 2k minus 13. And I'm going to put a box around that to tell you that is the answer. And so I say, if I feed a function a variable, it can work around it and it can do basic math as it processes, but it's usually not just going to give me back just a number because it's got that variable in there that's kind of like getting in the way, so to speak. So that's how you do this. And I've got a handful more examples now that we're going to just kind of trudge through, and then you can work for the rest of the hour. Got it? All right, it's one down, six to go. Our next problem, the function is f of x again. I got a little more creative after this, but this one was still just f of x. The function itself is the opposite of x plus 5. And I would like you guys to evaluate the function for f of negative 3x minus 5. So the goal when I teach is just, I feel like part of my job is just to translate information into words that help you understand it. All I'm asking you to do is pick up this stuff right here and go pop it up in place of that X right there. That's it. And to me, I find the most beneficial strategy for a student is to just be faithful to showing your work. Take the function rule that's in the purple box and copy it down. But when you copy it, change any variables into parenthesis sets. So it's going to say negative opening plus 5. That's just what's in the purple box recopied. And I'm going to feed into that slot this stuff. Do you see? That's functions 101. It's what you do. You make an opening, feed it, and then you do math. And our math today, again, is not resulting in a number. It's resulting in the algebra thing. So as we distribute, what is the first distribution? Positive 3x's. What's our second answer? Plus 5, because it has to change. When you distribute a negative, everybody gets changed. And then you copy down the straggler guy at the end, right? Anyone that was a part of the original function rule just has to continue to be a part of the answer. What is our final answer then? That's it. So the answer is 3x plus 10. So when I wrote these last five examples, I wasn't just pulling out random stuff. I was looking for every possible thing that's going to happen to you. So these last five examples are just going to be me trying to cover all my bases. The goal for me is always like, it's like a quest for me is, can I write the perfect lesson so that when my students get their homework, there's not a single problem where they go, wait, I don't know how to do this one. The goal is, oh yeah, we have one of those. We did it in our notes. So our next function, his name is h, and he's a function of a. And his job is to take 3 times whatever I feed him and then take away 7. We will be evaluating the function h at the value of m squared. And I tell you what, that could be really scary if you let it be. But this is actually a really silly, silly problem. This is the easiest one we've done yet. So the function rule is in the purple box. My job is to copy that function rule down. And every time I encounter a variable, I put a void. So there is 3 blank minus 7. What's going in the blank? M squared. So I take that out, plug it in there, and this problem is basically over. There's one little thing that I should do. This isn't called distribution because there's no plus or minus in there with the M, right? It's just done. All I got to do now is get rid of those stupid parentheses. They have no purpose. They were there for me as a teacher to show you where to put the stuff. But as far as what are they going to do now? Nothing. So you're just going to go 3m squared minus 7. Done. Simple pimple. Hopefully you would agree that that was the easiest one we've done yet. All right, the next ones involve fractions. So just kind of heads up. So our next function, would anyone like to guess his name? Nope, it's g. Would anyone like to guess what he is a function of? Nope, he's g of p. And his rule is he says, I'll take whatever you give me and I'll multiply it by -10. And then just for fun, I'll add 4 when I'm done. And we will be evaluating this function at the value of p over 2. Where I struggle as a teacher is when someone says, I just don't know where to get started. So for the fourth straight time, I will just show you 100% of the time how to get started. It's all about following directions. Okay, if it says g of p equals, everything after the equals sign is what we call the function rule. It's how he behaves. So we copy that down. But when we copy it down, every time we encounter a p or an x or a y or whatever, we change it to parentheses. That's an opening. It's a feeding slot. And then we're going to put a +4. And what are we going to put in the feeding slot? P over 2. So I'm going to grab this, pop it in. That's how functions work, man. We got a little issue here. I mean, some people really don't like fractions, but we're not scared. The first thing I would think of is I know for a fact that whatever's going on inside that red egg, I know this much. It's going to be negative, right? Do you see anything inside the red egg that we could do? I agree. I see simplify. I see a 10 and a 2, and I can reduce those. What is 10 and 2 reduced down? 5 and 1. The 1 is now rendered pointless because it's a bottom ones are, throw them away. So it's just -5p plus 4 done. In our, you see how the 10 and the 2 canceled each other to make a 5 and a 1? We will not be so fortunate in this next problem. So when I was writing my problems, I said to myself, I want them to see one where the fraction is what we call a friendly fraction. That's what I used to call these. To me, a friendly fraction is a fraction whose bottom plays nice with the other number so that he goes away. The other fractions I've been known over the years to call evil fractions. So this problem is going to involve an evil fraction. So we're going to have, anyone want to guess the function's name? He is f. Anyone want to guess his input? Nope, he's f of x. Look at that. I went with the old standby boring and you didn't guess it. And this function will do this. He says, feed me, and I'll multiply whatever you feed me by -3. And then when I'm done, just because I want to, I'm going to subtract 1. So that's his job. That's how he rolls in this world. And we're going to feed him x over 4 minus 2. And you can look at that and make as much out of this as you want. But really, I mean, I'll say it 50 times if you want me to. It's a matter of opening up a feeding slot and popping in what you're instructed to over and over again. So when I copy down what's inside the purple box, I'm just going to be aware of the fact that wherever I see that X, I'm going to put an opening. So it's going to look like -3, awkward opening, -1. What's going in that awkward opening? X over 4 minus 2. So I'm going to grab the food and stick it in the food slot. And now I'm going to do basic math. And as you can see, this time, this is not a friendly fraction because like in that last one, this number was a 10 and this number was a 2. And we're like, yeah, baby, I know that that makes 5. We don't have that this time. So really what we're left with is just accepting the fact that we're going to be left with a fraction. If the 3 and the 4 could be reduced, like if they were a 6 and a 4, I could knock them down to 3 and 2. But really, since they're just kind of like garbagey numbers, I'm just going to put it all together like this. I'm going to write -3x over 4 first. And I don't know about you, how you're feeling, but like if I were in my own class, I might want to raise my hand right now and say, how did you get that? So my explanation is this. I took the -3 and I put it over 1. And then I took the x over 4 and I didn't do anything. I left it alone because it's fine. And then I just looked for anything I could reduce and said, No, nothing. So I go, boom, top times top. What do you get? 3x. Bottom times bottom. What do you get? And there you go. So when fractions don't play nice, it's okay. Just make a fraction. It's all good. Now we still have a little math to do. I got some distribution right there. What does that make?
6.
So plus 6, and then copy down the -1. And we're almost home. What is the final answer? Yeah, baby. That should be the hardest one. I have two left, each of them with a specific purpose, but I knew in my mind that example 5 would be the one where if anyone was going to go, uh-oh, it would be that one. So there'll be a couple of those on the assignment with the evil fractions. Number 6 out of 7. Anyone want to guess the function's name? What'd you say? G. Yes, it is G. Garrett or Seth got the function's name. Do you want to guess the input? It's not X. Nope.
E.
It's the first initial of a man who in his career
A.
is the last name of a man who was notorious for like jumping motorcycles over like the Grand Canyon and stuff like that.
Oh, wait.
Do you guys remember who that guy was?
C.
He went by the name Evil Knievel.
Okay.
K. He was OG. Like you see all the Red Bull guys nowadays who do those amazing things. Every one of them is amazing. They all would probably tell you that they are aware of and inspired by the great Evil Knievel. So if you ever on YouTube and like, oh, you're getting tired of watching like K-pop videos or whatever, or anime or whatever nonsense you're watching, hop on over and watch yourself an Evil Knievel video. That guy was the OG. Evil Knievel, baby. Anyhow, our function is named G. He says, I process Ks, and he is a simple man. That's him. He says, I live a very boring life. As a function, here's what I will do. You feed me, I'll multiply it by 5, and bam, we're done, baby. And we are going to feed into him that. And if in example 6, you still have the question of, I just don't know how to get started, I would begin at this point to maybe question your motivation. I'm going to take the function rule, which is in the purple box, and I'm going to copy it down. And when I get to the part that says letter, I'm going to put a void. And what am I putting in the void? The food, zoop, goes right in there. And this is another one of those that's so easy that someone might try to make it difficult. What is 5 times -6y? -30y. Done. And then the last problem you'll also probably find to be relatively simple. This really will boil down to who's willing and who's not willing just to show some work. If you're having issues with this, you would want to go back and watch the video and say, am I doing what he said to do in the order that he said to do it? And if you're not, then don't be surprised. So last one, and then it's worky time. Does anyone want to guess the function's name? Nope. Nope. It is the first initial of a very famous old 100 years ago magician.
C. H.
H for Harry Houdini. Well played. And what letter are we going to be processing? It's the first letter of an instrument often found in the percussion section of a like a marching band.
B.
It has little mallets and little bars.
X.
X for xylophone. So Harry Houdini xylophones. You can see like this is what I when I'm sitting at home. So I wanted you to be comfortable when you get the worksheet with the fact that you're going to get like P of K, J of R, F of like it doesn't matter. It's just a function, right? So it can be any name and it can be any variable for processing. It's irrelevant. When we start doing functions later, like word problems, like I want to write a function for the cost based on the number of products that I manufacture, then I will write a function specifically called C of M. That will be on purpose cost based on manufacturing, right? But for now, it's just arbitrary. It's just letters. This function does the following. He says, whatever you give me, I'll multiply him by -4, and then I'll add 13 because I feel like it. And I'm going to feed him -x. Oh boy, that's not a lot going on there. So for the 7th straight time, I will model for you how to do this successfully. Identify the function rule, copy it down,
-4 minus x plus 13.
put a blank. What do these parentheses indicate other than just a blank? What do they show us in math? They're timesers. Good. So when I feed in the -x, I realize now, oh, careful, that's a -4, and that's a -x. It'll make it a positive 4x plus 13. Do you have any questions about that? That is the final topic for now that we will talk about. The next time we work tomorrow, it won't be a lecture. It'll be here. Let's now start showing that we know how to do all the stuff we've done when it comes to functions. That's what practice quizzes are for, is let's bring that package all together and put a nice little bow on it.
Yes.
You should write your answers with the variable part first. So let's say you're working through a problem and you just naturally working the problem out wind up with 5 minus 2x. I'm not going to say that that's wrong, but you're going to have to be prepared for the fact that that's not how I do answers. It's not how math people like answers. We write our polynomials in standard form, and what that means is that variables should go before numbers. And so I would take the -2x and put it first, and then the +5 and put it second. You're not going to find a ton of math people that disagree with that sentiment. You probably will find few that are as uptight as me about things, but the fact remains, writing answers with X's first is a good habit. So for the 6 of you that were listening to that, I hope that sunk in. Just telling you that because when you look at your answer at the answer key eventually, I don't want you wondering like, is this right or is this wrong? It's probably right. It's just in the order that I don't like. Number 3, sure. So our functions, so this is number 3, and our function's name is f, and he processes x's, and he takes whatever you give him and subtracts 1. And we are plugging in -2 minus x like this. So I'm going to take the purple box, and I've tried to be as consistent as I could be throughout the last 45 minutes or 30 minutes, but like that's what I want to see. That's the function rule. And I'm going to copy that down, and I'm going to put blank -1, right? Yeah. And into that blank, I'm going to deposit the food. And you would see in a case like this that it turns out that my parentheses really don't have a purpose, so I could now get rid of them. I like having them just to show you guys that this is the opening where the food's going to go. But at this point, you would realize like there's no number in front of it to distribute or whatever, so I'm good. So what I would do personally is I would take the X part first, and since he has no one to go with, I would very purposely filter him to the left because I want that first. And then I would take my numbers, my -2 and my -1, and I would add them together to make -3. And I would put that at the back. And I'm done. You good? All right. So problem number 1. The first thing you're going to do, well, I'm going to copy the problem onto the board. Okay, so the problem says that P is a function of X. And what he does is he multiplies whatever I give him by 3, and then he adds 3. And I have throughout the lesson been putting a box around this because I want you to understand that this is where all the action happens, okay? Yeah. So I'm going to take, and in this, when I copy this purple box down, I'm going to put 3 times a big empty blank plus 3. Are you still with me? Right. And so since we were asked to evaluate negative 4x, we're going to put that right in there. Yes?
So do you have the answer keys?
Yeah. Yeah. Give me just a second. Okay. And then what would we do after that? Is this where you get stuck? Okay, so now it's just time to do math. So like all the algebra has been done. You've done everything perfect to this point. Like, did you get this far? Then you're the man. Like all that's left to do now is just perform this multiplication problem. Yeah, and it's you don't even really want to call it distributing. The only time I would call it distributing would be if it said something like this. If it said like negative 4x plus 2, you see, if we have this extra guy at the end, then we have to call it distribution. But if there's just one thing inside, like in this case, you don't even really want to think of it as distribution. You just want to call it multiplication. Negative 12x, because when you multiply a positive and a negative, you get a negative. And then all you got to do now there, G, is just take that plus 3, slap it on the back, and you're done. You got her? You want to do another one together? Problem number 2. Okay, so in problem number 2, the function is this. I'm just going to save a little time here. It's 2x, right? That's where x used to be, plus 1. And what are we feeding into that opening? Nice job. Now you can use the word distribute, Garrett, because there's more than one thing. Plus and minus in the parentheses make us distribute. So we're going to go ahead and distribute. What is 2 times 4? And then what's this second half going to be? Nice job. Now, at this point, that's a really good answer. It's just not done. So this is what I was talking about 5 minutes ago. What you want to always do is go in and find your x's first and get them filtered and combined over to the left. In this case, you would agree that this negative 2x has no homies to go with. So he's just going to move himself. And he says, I'm going to go ahead and go first because my teacher's a bully and wants me to put my x's first. And then I'm going to take the 8 and the 1 and add them together. What do you get? So I'm going to put a plus 9 at the back and I'm done. You rolling now? All right, buddy. What's up? Number 5? Sure. So in number 5, the function says this, and I'm gonna start cutting some corners since you have the problems on your paper. So the function says to do 4 times whatever I feed it minus 3, correct? And what am I going to feed it? So I'm just going to stick an a squared in there. This is like one of our examples. It was, I don't remember which, it was example number 3, where there's really nothing left to do except just clean it up, right? Sometimes people say, well, should I distribute? And that's not appropriate because you would only distribute if there was something else in here, like a plus 2 or a minus 5 or something. So that's not a valid thing to say. All I simply do is acknowledge that this is just a multiplication. And I'm just going to take the parentheses off because they look creepy. Like, I put them there because it's my job to show you what we're doing. We're putting stuff into empty spots, right? But really the answer is just this. Done. Isn't that boring? Right. I mean, the better you get at this, when you really start rolling through this and cooking on it, you wouldn't even probably ever have those parentheses because like when you see an easy problem like this coming, you might just put this right away, like as your first thing. Right. Yeah. So
I'm worried about put this one, put it in -3 or it's negative.
negative. Yeah, because that's like a positive times the negative, which is a negative.
Negative.
Yep.
Number 3 is actually not an one. And so when I put the parentheses, do I not put X?
Yeah, you don't put X anymore because the parentheses take the place of the X. So like, here's what the problem looks like. It goes like this. It goes, ready? X minus 1, right? Now what's going in the parentheses? In this one, I just went over this with someone else, but you were working on something else. These parentheses, it turns out, serve no purpose. They're just there for me as your teacher to show you an opening to put something in. But in reality, so like Garrett, if there was like a 3 here, then it would be like, oh, these are important parentheses because I got to distribute. But if there's nothing in front of the parentheses, then they don't even really, in hindsight, need to be there. So now our only job is just to clean it up. What are we going to put first? The X part goes first. So move him out to the west, negative X. He's negative. Just put these together, brother. What's -2 minus 1? Nope. If you owe me $2 and you borrow one more, that's it. Morning. Glad you could join us. Yeah, this is what I call an evil fraction, because you can already see it coming down the pike that the bottom of the fraction is a 3 and the number it's going to multiply by is a 4, and those don't play nice. So this will be like one of our examples where we just kind of suck it up and make a fraction. So it's going to look like this. So the function says to do -4 times a food slot. And it turns out that's too big of a food slot. I'm going to make it a little smaller. -1. Good. And then I'm going to feed into that food slot this, right? So at this point, again, what I'm always looking for is, can this number and this number be reduced? And the answer is no. So we're just going to blend it all up, Gunner. We're just going to say -4n. We're going to stick it over 3. And we're done. Got it? Okay.